Hey guys, this is Worm from Worm's Maths Academy. Pain in the ass because I have to do this video again. I actually did it a few days ago, but for some reason the sound cut out at 6 minutes. So hopefully this one isn't the same. The good thing is I should know how to do it now. No, I don't know whether I don't think I made any mistakes on the last one. Maybe I'll stuff it up now. Okay, so how many questions have we got? 9 questions. Same as usual, 15 minutes reading time, 1 hour writing. We're just going to smash it straight out. They ask us to find the derivative of e to the 2x over 2x plus 1. Of course, in this case, we would use the quotient rule. U is e to the 2x. V is 2x plus 1. U dash is 2e to the 2x. V dash is 2. So we can say d dx of e to the 2x on 2x plus 1 is v times u dash, 2e to the 2x times 2x plus 1 minus 2e to the 2x over v squared, 2x plus 1 squared. I don't think they'd take a mark off if you didn't simplify it, but this here, the 2e to the 2x minus 2e to the 2x, they will cancel. So we're left with 4x e to the 2x over 2x plus 1 squared. Okay, here we're going to use the chain rule because when we rewrite it, we end up with sine 2x to the power of 4. So we've got a function inside another function. So we would let u equal sine 2x, therefore y is u to the 4. When we derive sine, we get 2 cos 2x. When we derive u to the 4, we get 4u to the 3. So we would say f dash of x is 8 cos 2x, then u cubed, so sine cubed 2x. Now I know you can do this a fast way by skipping, like writing out the quotient rule and the chain rule. I'm just doing it because people may need to know how to work it out. F dash of pi on 4, 8 cos of pi on 2, sine cubed of pi on 2. Cos of pi on 2 we know is 0, because if you draw a little cos graph, there's pi on 2, goes through 0. So we know overall that whole thing is 0. Okay, here we've got to show that question. So I would say u is x cubed, u dash is 3x squared, v is log e 2x, v dash is 1 over x. Remember, when you differentiate a log, it's the derivative of the bracket over the bracket, which in this case is 1 on x. We know h dash of x, because it's show that, I'm just going to show all of my working. 3x squared log e 2x, we cross them, plus x cubed times 1 over x, 3x squared log e 2x plus x squared. You don't want to lose marks when you don't need to, if that makes sense. You don't want to lose marks for not not showing working, and it only takes a second to write it out. Okay, now we want to anti-diff dy dx is equal to this, which we know is this here. So we can say y is the integral of 3x squared log e 2x dx, but we know that's the same as the integral of h dash x minus x squared dx. Because if I bring this to the other side with the h dash x, I get h dash x minus x squared. The good thing about that is y is the integral of h dash x, which is hx, minus 1/3 x cubed plus a constant c, and we know h of x is x cubed log e 2x minus 1/3 x cubed plus c. We know when x equals a half, y equals negative 25 on 4. Always be careful because I nearly didn't see that negative. Negative 25 on 4, 24. Okay, we get negative 25 on 24 is equal to, if I sub a half into that, it's actually 0 because log of 1 is 0. If I put a half into this, I get negative 1 on 24 because a half cubed is an eighth, and if I multiply it by a third, I get 1 on 24 plus c. If I add 1 on 24 to the other side, we get therefore c is 1, because negative 1, sorry, negative 1, because c is negative 25 on 24 plus 1 on 24. So we can say y is equal to x cubed log e 2x minus 1/3 x cubed minus 1. Now hopefully I haven't stuffed anything up in this one or anything previous. Okay, Steffi is raising, it's a lot of words here. Steffi is raising money for a school with a lucky dip. In this game, 100 identical cubes numbered 1 to 100, placed in a large container. The container is then thoroughly shaken. A player pays $2 to play the game, and they're blindfolded so they can't see. The player then selects a random. If the number on the selected cube is a multiple of 10, so 10 to, thank you for explaining it to us, the player wins a cash prize of $7. The cube is then returned to the container, which is then shaken again before the next one. Okay, so it's independent of the next one. Find the probability will win the $7 cash prize. Well, we know that's 10 out of 100, which is 1/10. What's her expected loss? So we know when she plays, we'll say X, she can lose $2 or she can win $5. We just found the chance of winning $5 is 1 on 10. So losing is 9 on 10. So we can say E of X is negative 2 times 9 on 10 plus 5 times 1 on 10. Negative 18 on 10 plus 5 on 10, which is negative $1.30. So I say therefore she expects to lose $1.30 per game. Okay, p hat is a random variable that represents a proportion of 1 by a player in random samples of 3 games played. So find the probability that P hat is equal to 2/3. So we could say X is binomially distributed. Let's use Y. 3 trials and our chance of winning a game is 1/10. We say the probability that P hat is equal to 2/3 is equal to the probability that Y is equal to 2, because she would win 2 out of the 3 games. We know that is 3 choose 2, 1/10 to the 2, 9/10 to the 1, 3 times 1 on 100 times 9 on 10, which is 27 over 1,000. Okay, not too bad so far. Let f be defined for all real numbers. 2e to the x. I'm just going to, this is a Fogs and Goffs question, so I always just put domain range. F and G are greater than 1 because it's an exponential. This one is from -2 to infinity, and it's going to have a range of all real numbers. Find f of g of x in the form ax plus b. So f of g of x is 2e to the log e x plus 2 plus 1. We know that they effectively are inverses, so they cancel each other out. 2x plus 2 plus 1, 2x plus 5. Now, our domain in this case, state the range of that function. Here, the range of g is equal to the domain of f, so the domain of f remains unchanged, which means the composite function f of g of x has a range of 1 to infinity, i.e. it hasn't changed because the range of g is exactly the same as the domain of f. Also, we could say the composite function has a domain of -2 to infinity. If I put -2 into this, I get -4 plus 1, which is -4 plus 5, which is 1, and then it's only going to get larger. Okay, let the graph of the function h be the transformation of the graph of the function g under t. If h is equal to f inverse of x, then fine. Okay, h be the transform h is the inverse of f of x. So here we say x is equal to 2e to the y plus 1. 2e to the y is x minus 1. Actually, let's do this over here. So what did we say? X is equal to 2e to the y plus 1. So we're going to get y is equal to log e x minus 1 over 2. Let the graph of the h be the transformation of the graph of g under t. So here we've got to get this transformation. X dash is x plus c, y dash is y plus d. X is equal to x dash minus c, y is equal to y dash minus d. This transformation has to be applied to this graph. So we get y minus d is equal to log e x minus c plus 2. Y is log e of x minus c plus 2 plus d. Now these have to be the same. When you look at it, you go, hang on a sec, this doesn't have a denominator, and this one does. If we've got log e of a over b, we can say that's log e of a minus log e of b. So we can rewrite this to be y is log e of x minus 1 minus log e of 2. Now we can equate what's inside the log and the constant at the end. So we get x minus c plus 2 is equal to x minus 1. The x's cancel. We get c is equal to 3. And then we get d is negative log e of 2. So for that to make sense, we needed to equate the coefficients. And then, because we couldn't just directly equate them, we needed to use log laws to split them apart. Okay, part of the graph is shown. Let G be negative 1 to 2, so the missing part. Sketch that graph. It's exactly the same. Okay, so it's going to go through there, turn there, turn there. Hasn't been reflected or anything, has it? And it's going to join up at those points. So now it's going to go up, and then it's going to go down, and it's going to go up. Okay. Sketch the graph of G. Doesn't say you have to label anything. So that looks good. All right. Find the solutions to g of x equals 0. So we just want it on this domain. So I can say sine pi x equals, if I bring the 1 to the other side and divide it by negative 2, I get a half. We know sine is equal to a half when x is pi on 6. So we say pi x is equal to, sine is positive in the first quadrant, pi on 6, and in the second quadrant, 5 pi on 6. You can see if we put a half, we would get two solutions, there and there. So if I divide through by pi, I get x is 1/6 or 5/6, which that looks like it's about 1/6 and that's about 5/6. Find the area of the region bounded by the graph of G and the x-axis. So the only region that's bounded is this one down here. So we want to find out what that is. Remember, that's a negative area. So we can say our area, instead of going from 1/6 to 5/6, we're going to go from 5/6 to 1/6 because we know that the area is negative and we want to make it positive. When we antidiff negative 2 sine pi x, we get 2 on pi cos pi x. When you antidiff sine, you get negative cos. and you've got to divide by the coefficient of x, plus x between 5 on 6 and 1 on 6. If I sub 1 on 6 in, I get 2 on pi cos of pi on 6 plus 1 on 6 minus 2 on pi cos of 5 pi on 6 plus 5 on 6. Okay, cos of pi on 6 we know is root 3 on 2. Root 3, there's pi on 6. So I get 2 on pi times root 3 on 2 plus 1 on 6 minus cos of 5 pi on 6 is the same thing but negative. So we get 2 on pi times minus root 3 on 2 plus 5 on 6. We know they cancel. They cancel. I've got root 3 on pi minus root 3 on pi, 2 root 3 on pi, and then I've got 1 6 minus 5 6, which is minus 4 6, or 2/3 square units. Okay, the next one. A and B are events for a sample space such that the probability of A is a probability of B given A. Probability of B given not A is 1/4. So we know the probability of B given A is the probability of A intersects B over the probability of A. So we can say the probability of A intersects B is the probability of B given A times the probability of A, which is 2/3 times 2/5, which is 4 over 15. The probability of A intersects B not is the probability of B given A not times the probability of A not. We know that's 1/4, and we know the probability of A not is 1/3, so that is 1/12. The probability of B is the probability of A intersects B plus the probability that A intersects B not. I think it's called the total law of probability. 4 over 15 plus 1 over 12. They both go into 60. 16 over 60 plus 5 over 60 is 21 over 60. They're both divisible by 3. 7 over 20. So this, if I say the probability that A intersects B, there's A, there's B, that's A intersects B. The probability that A intersects B not, the probability that, A intersects, probability that A intersects B not. A not intersects B. Put that around the wrong way. I'm like, that doesn't make sense. The probability that A not intersects B. So that should be A not. All the maths is right. The probability that A not is everything not in A, but where does that intersect B? It intersects it here. So if you add those two together, which is what we've done here, you get the probability of B. I'm sure it's called the total probability. Okay, find the probability of A naught or B naught. A naught is everything not in A. B naught is everything not in B. That's A intersects B. The probability of A naught or B naught is 1 minus the probability of A intersects B, which we have up here. So that is 11 on 15. Okay, how many questions is there? 9. Seems a little bit, but no, whether it's long, I don't know. Okay, a rectangle is inscribed between the graph of the function q and the x-axis. Its vertices are A units, where A is greater than 0, the axis symmetry is x equals 2. Find the value of A when the rectangle is a square. Give your answer in that form. Okay, so if we know that's 2 and we're going up A and down A, this bottom length is 2A. And we know this side length is q of 2 plus A or q of 2 minus A. So let's first find q of 2 minus A. We get 2 minus A, 4 minus 2 minus A, which is 2 minus A, 2 plus A, which is 4 minus A squared. So we know it's a square when side lengths are equal. So we can say 2A is equal to 4 minus A squared. A squared plus 2A minus 4 is 0. It's not going to factorize because we know it's got a square root in the answer. So A squared plus 2A, halve it and square it, we get plus 1 minus 5 is 0. A plus 1 squared is equal to 5. A is negative 1 plus or minus root 5. A is greater than 0. So the only one that's going to be positive is A is negative 1 plus root 5. B is an integer and C is a positive integer. Okay, that's fine. Find the maximum area of ABC to give your answer in that form. Okay, so we know the area is the product of those two. So area is 2A times 4 minus A squared, which is 8A minus 2A cubed. dA equals 0 for a max/min. So we know in this case, 8 minus 6A squared is 0. So we get A squared is 4 over 3. So A is plus or minus 2 on root 3. A is greater than 0, so A must equal 2 root 3 on 3. So all I did was rationalize it. Our area, if I've got 2 root 3 on 3, is 2 times 2 root 3 on 3, so 4 root 3 on 3, multiplied by 4 minus A squared, and we know A squared is 4 on 3. So we get 4 root 3 on 3. That's 16 on 3 minus 4 on 3. So 16 on 3 minus 4 on 3. 12 on 3. Is that right? No, 12 on 3 minus 4 on 3. which is, put that over 3, we get 12 on 3 minus 4 on 3, which is 8 on 3. So we get 32 root 3 on 9. So here, max area is 32 root 3 on 9. Okay, that was a short question. It's all right. The graph of this between 0 and 4 is given by that function. That function is 2x, so that's y equals 2x. Find f dash of x. So firstly, f of x we know is 2x minus x to the 3 on 2. F dash of x is going to be 2 minus 3 on 2 x to the half, or root x. The tangent of the graph of the point B is perpendicular to the graph of G. Find the coordinates of B. So if it's perpendicular, we know that the two gradients, f dash of x will equal, if that's got a gradient of 2, the perpendicular gradient is negative a half. So we say 2 minus 3 on 2 root x is equal to negative a half. If I bring my 3 on 2 to the other side, root x, and then I bring my half to the other side, 5 on 2 is equal to 3 on 2 root x. We can cancel the 2's. Root x is equal to 5 on 3. So x is equal to the square of these, 25, over 9. Which is nice because we've got to sub it back in and say f of 25 over 9 is 25 over 9. 2 minus the square root of 25 over 9. 25 over 9 times 2 minus 5/3, which is 1/3. So we get 25 over 27. So B is 25 over 9, 27. Is that right? 25 over 27. I think that's all good. Okay, show the graphs of f and g only intersect at the origin. All right, so 2x minus x to the 3 on 2, is it? Is equal to 2x. Therefore, negative x to the 3 on 2, because the 2 x's will cancel. Therefore, x is equal to 0. When x equals 0, y equals 0 times 2 minus root 0, which is 0. So therefore, the only intersection occurs at 0, 0. Okay. At Q2Q, where Q is greater than 0, but the point of the graph of G, the tangent of the graph at the point D passes through Q, as shown below. It can be shown that D is equal to 3Q. So whatever that point is, this one is 3 times as far away from the axis. Determine the values of Q for which the tangent of the graph passes through Q, and has an x-intercept greater than 4. Okay, so D could move anywhere here. That'd have an x-intercept greater than 4. When we get to the turning point, it's not going to have an x-intercept because it's parallel. So we've got to work out what that turning point is. Or we already have maybe. And then we also know at the point 4 that it'd have an x-intercept of 4. But it says greater than 4. So we know D has to be less than 4, this point here. Therefore, 3Q has to be less than 4. So Q has to be less than 4/3. This point here, the turning point, have we found that? No, but we can. F dash of x equals 0 gives us 2 minus 3 on 2 root x is 0. So we get root x. If I bring it to the other side, multiply the 2 across and divide it, I get 4 on 3. So we get x is 16 on 3. So that's 16 on 3. So we know D has to be greater than 16 on 3. So 3Q has to be greater than 16 on 3. So Q has to be greater than 16 on 9. So therefore, the x-intercept to be greater than 4, 16 on 9 is less than Q, which is less than 4 on 3, because it's got to be greater than, Q has to be greater than 16 on 9, which is what that says, and Q has to be less than 4 on 3. So hopefully that makes sense. Because if you had a tangent that's parallel to the x-axis, it's never going to come down and intersect. So anything that's like, tangent. At that point, the turning point's never going to intersect. Anything over here will also never have an x-intercept greater than 4. Okay, now I remember saying this one the other day and thought, what the hell? And I still think, what the hell? Because this is like specialist math. Because it's basically a differential equation that we would solve in Spec. And I think this could stuff quite a few Spec kids up, because they might spend a while trying to work this question out. The first thing it does is it tells us that the function, the second thing, first it tells us it's continuous. When it's differentiable, we know it's continuous for all real values. It then says that all of our values lie between 0 and 4, but it can't include 0 or 4. So here, if I say y equals 0 and y equals 4, our range is between those values, and it also says that our gradient is a factor of y4 minus y. The first thing it says, f dash of 0. So here, if we sketch f of x against y, we know the range is from 0 to 4, and we know f of 0 is 1. So if that's 2, it's going to be 1 down here. If we look at the rest of it, if we were to sketch f dash of x against y, we know if that's f dash of x and that's y, we know this is going to have two y-intercepts. It's going to have one at 0, and it's going to have one at 4. And it would be a parabola, an upside down parabola, which is going to have a turning point at 2. And when we sub y equals 2 into this equation, we get 2 times 2, so we get 0.24. Now you might say, why did I make those endpoints open circles? Because we know that's when the gradient equals 0, but in actual fact, the gradient doesn't exist at 0 or 4 when y equals 0 or y equals 4. So I've sketched the original, I've got the original function. We know here the gradient's positive, 0, and then positive. Sorry, not 0, positive. It's positive, increasing. It gets to its maximum slope when y is equal to 2. This is against x. And then it goes back to 0. So it's not defined. It goes up until its maximum gradient, and then it goes back to 0. So that's what our original graph's going to look like, because it's a strictly increasing function. Now, from here, find f dash of 0 if f of 0 is 1. So we know f dash of 0 is f of 0, 4 minus f of 0, which is 1 times 4 minus 1, which is 3. So hopefully most people would get that. The second one, determine with appropriate justification the number of stationary points of the graph of f of x. So we say f of x has no stationary points as f dash of x equals 0 when f of x equals 0 or 4. However, f of x isn't defined. F of x only defined from 0 to 4. So f of x has no stationary points as f dash of x equals 0 when f of x equals 0 or 4. However, f of x is only between 0 and 4. Hence, f dash of x can't equal 0. Therefore, no stationary points. And that makes sense. If you look at our graph of f dash of x versus y, we know that it never actually equals 0. State the range of f dash. Well, we've got f dash here. We know that it can't equal 0. So we say x is an element, or y, or f dash, is an element of 0. And the maximum value that it can have is 4. And that can be inclusive because that's when the gradient is the steepest and it has a gradient of 4. Now, I actually think this question could be worse for special kids because they might try and say dy dx is y, 4 minus y, and then try and flip it and anti-diff it, and you don't need to do any of that, which makes sense by all the 1 markers. I don't like the question, though. I still think it's not fair. Yeah, so if it was going to have stationary points, f dash of x would equal 0, and we would have y is equal to 0 or y is equal to 4, but we know y can't be 0 or 4 because it's not defined. The range is only between 0 and 4, but it doesn't include 0 or 4. Okay, hopefully this one, the sound worked the whole way through. Good luck on your exams in a couple of weeks. Bye.